In this tutorial, we will train and use a YOLOv8 OBB model with ros-2 to detect bolts scattered on the table. As we can see, bounding boxes of the bolts are rotated, which means that we can calculate orientation or rotation angle of bolts. This technique can be useful for various applications in robotics. So, what is OBB? OBB stands for Oriented Bounding Box. In usual object detection, bounding boxes are axis-aligned rectangles like in the left image. But in case of oriented object detection, bounding boxes are rotated. Oriented object detection has several applications. The most common one is aerial photography. Small objects can be detected much more precisely using this technique. So, it can be used to count objects in an area. The second possible application is picking up small objects using a robotic arm. Since we know orientation of the objects, it should be easier to plan arm movement. Here is the training data we will use. It is just 10 images. Each image contains 13 bolts. During the annotation process, we will draw a rectangle that will precisely surround each bolt. Now, let's do the annotation. For annotation, we will use this Label Image 2 tool. The instructions for installation are written on this page. We will use this tool with Python 3, so we should follow these instructions. Firstly, install PyQt5 DevTools. This package contains various support tools for PyQt5 developers such as User Interface Compiler, Resource File Generator and Translation String Finder. Next, install the LXML package. LXML is the most feature-rich and easy-to-use library for processing XML and HTML in the Python. It is mature binding for the C libraries libxml2 and libxslt libraries. It provides safe and convenient access to these libraries using the element tree API. After installation of these libraries, clone Label Image 2 repository. To run the tool, move to the Label Image 2 directory and execute the Label Image Py script. After the tool window appears, click on File. Select Open Directory. Select the directory in which the images you will use are placed. Depending on which PyQt5 version has been installed, an error may happen. This error occurs because float type variable was passed to drawLine method, whereas integer type is required. Here is the part of the code where the problem occurred. We should modify lines 678, 685 and 686. We should cast each coordinate variable to integer. We have to do one more thing. Move to the data directory. Open the predefined classes text file. Add the bolt class to the very top of this file. Now, let's do annotation once again. Select the Draw a New Rotated Rectangle Box button. Using the left button of the mouse, draw a rectangle nearly the same size of the object you want to annotate. Move the mouse to one of the corners of the rectangle. Select this corner with the right button and rotate the rectangle so that it becomes parallel to the object. Note that dotted line represents origin, so in our case, it should be pointed to the head of the bolt. Then, move the rectangle above the object. Let's annotate another bolt. If the rectangle is too small or large, adjust the size of the rectangle. Once all bolts are annotated, we should have rectangles around all bolts like this. Install Ultralytics package. To train YOLOv8 OBB, we need data format that is described in this page. Each object is described by class index and coordinates of 4 vertices normalized between 0 and 1. But data that label image to outputs by default is in XML format. So, we have to convert our data. We will do this in 2 steps. Firstly, using this YOLOv8 utils repository, we will convert XML files to DOTA format text files. DOTA format is described by coordinates of 4 vertices, category index and difficulty. Note that these coordinates are not normalized. Now, clone this repository. Execute the voc2 YOLOv8 OBB py script. Here we should specify path to the data for training and path to the file in which class are specified. After execution of this file, text files will be generated. As a second step, we should convert this data to the YOLOv8 OBB format. Please download the YOLOv8 OBB training zip file and extract it to your home directory. We will use the format converter py script. This script is based on the convert DOTA to YOLOv8 function. But it is modified so that directory structure also can be used for training. Note that in class mapping dictionary, index value of each class should be the same with the order of classes in the predefined classes text file we used previously. Now execute this script. After execution, YOLOv8 format labels will be generated. In this tutorial we used 8 images for training and 2 images for validation. In the train info YOM file, we should specify path to the dataset, path to the images for training and validation. Test images are not necessarily required. Under the names, we specify index and class name. Now we are ready to execute training. Open the YOLOv8 OBB train py script. There are several ways to train custom model. In this case, we will use pre-trained weights. When learning executed for the very first time, weights file will be downloaded automatically. Here we are specifying data file, number of epochs and image size. To begin training, execute this script. Training will take several minutes to complete if you are using GPU. Results will be generated in the runs directory. And trained model is placed in the weights directory. Copy this file to YOLOv8 OBB training directory. To test our model, execute the YOLOv8 OBB inference py script. Results will be generated in the detect directory. As we can see, the model was successfully trained. By executing YOLOv8 OBB webcam py script, we can do inference using web camera. Now let's see ROS2 code. In the YOLOv8 OBB message package, custom message is defined. For detailed explanation of how to define custom message, please see this tutorial. But there is a difference in the inference result message. This time, we have 8 coordinates. So, instead of defining variable for each coordinate, we have defined one array. There is one thing should be mentioned regarding the YOLOv8 OBB publisher Pi script. Here, we obtain rotated rectangle coordinates as two-dimensional array. But as I mentioned before, since we can publish only one-dimensional array, we transform this array to one-dimensional array. Accordingly, in the YOLOv8 OBB subscriber Pi script, we transform received message back to two-dimensional array. For a RAW's USB camera driver, we will use this package. This package can be installed using apt. So, install it. Now, build the packages. To run the code, execute YOLOv8 OBB launch file. To make sure that our custom messages are published correctly, run the YOLOv8 OBB subscriber Pi script. Open our viz. Visualize the inference result topic and the inference result CV2 topic.